Okay, this is my final year project. It's an Avr. It's going to control this generator right here. The generator is going to be driven by this induction motor, and the speed is going to get held constant by this drive here. As you can see, when the Avr is supplied 8 volts, it draws 0.38. This current is mainly due to the backlight of the LCD. This oscilloscope here is going to show the PWM getting fed into the CPIC circuit, controlling the amount of current that enters the exciter here. You can see the red wire, that's the positive part of the exciter, and the negative is ground. That's connected to the Avr, as you can see there. So the first test that I'm going to do is check the limit of current into the exciter. So the generator is going to be switched off, and I'm going to get the Avr to find the PWM that should give a reference voltage of 24 volts, but it won't be able to get the reference voltage of 24 volts because the generator rotor is not spinning. So initially it asks you to press the voltage. I'll change that to a choose a voltage. It's not going to say press a button, but if we press a button here, this button is for the 24 volts, so I'm going to press that. The PWM is searching for the PWM. It ain't going to be able to find it because no voltage is getting induced onto the output of the generator because it's not spinning. As you can see, the maximum current, what the Avr limits into the exciter, is 2.05. This will also get changed to 2.5 later on. But I pressed the 24 volts. Now that I start spinning this rotor, the PWM is going to start changing. When it gets to an appropriate speed, you should see the current reduce as well, because as the PWM reduces, yeah, there we go, it's going to find 24 volts. Okay, that looks like it's found it, even though it's speeding up. Let's have a look. Yeah. It's saying 25 or 26 volts, but we can rectify that. Let's just get up to maximum speed. As you can see, 100 Hz. When I press that, I can change the reference. You can see the reference voltage is held now. Yeah. Let's switch on a load over here. The voltage is kept constant for all 3 phases. And when I switch off the load, it should remain. You can see it regulates it back down to the 24 volts. Still. Yep. It's holding the output voltage. At any time, the user can press the reset button, this red one here, and it will switch the PWM off. And that will reset the whole program, asking you to select a voltage again. Now let's try the 12 volt button. The PWM stable, that means the voltage is ready. As you can see, it's 12 volts now. I added in reference buttons where you can change the feedback reference, so we could effectively get any voltage that the user required. And let's add in a load for again for this voltage. Hold at 12 volts. The other two loads still at 12, and the last one, as you can see, it's effectively regulating the exciter current to keep the output voltage constant. There's the load. I'm just going to switch it off now. Yeah, turns the PWM off, and the switch that's there. No current enters the AVR.